Welcome back. I think our next speaker needs little introduction for most of you. But just in case, Bill is the project manager of the Blue Waters at NCSA and the University of Illinois, my alma mater. And he was here at NERSC for 12 years. I think your title was NERSC?
General Manager.
General Manager, that's right. So one thing you may not know about Bill is I looked on his resume, and I think it said that you had brought in more than 20 large supercomputers, and 7, and maybe it's now 8, had been in the top 5 of the top 500 during that time.
It still stays at 7.
Still stays at 7. Oh, that's right. Anyway, welcome, Bill.
Top 500 capable, yes. So I'm very happy to be here and very honored to be asked to talk a little bit at this event. What my goal is just to take a step back. We had an awful lot of fun hearing about reminiscences and things that went on our individual basis in the early days of NERSC. I want to take a step back and say, what has NERSC contributed to supercomputing overall, the supercomputing community? We have heard some of the impacts NERSC has had scientifically. I wanted to take a step back and look at it from the supercomputing community and give you my thoughts on what NERSC has done. These are entirely random thoughts. They're mine for about 100 million time of improvement in performance. We heard a little bit about that a little bit earlier, about what we can do today versus what we could do many years ago, 40 years ago. So it's spanning a lot of that time. The other thing is, when Francesca sent me an email asking me to participate as an old-timer, I objected to that. I don't think that fit my self-image of this, but she persisted in saying, well, that's all right. But because now she's labeled me as an old-timer, I'm going to use the prerogative of old-timers in my talk, right? So the first one is, these are my thoughts. They're based on many supercomputers, many storage systems, facilities, many users and science projects. I come from in being involved with 3 world-class organizations in high-performance computing, and having worked in industry, national centers, governments, and having many relationships. So the first thing is, these are my thoughts, and they're not scientifically provable. I may get some of the details wrong. I'd appreciate any of you correcting the details after. But I think the statements are, the message is correct. And I can hide behind not getting everything precisely detailed, because first, some of you know I don't do details. Second is, I'm an old timer and I may not remember things correctly. I'm going to talk about things that I'm interested in or that I remembered over the last couple days, particularly flying here last night. Don't take that to mean any contributions any other organizations have made. It is, after all, NERSC's birthday anniversary, so we're going to talk about NERSC and ignore all the other contributions that have been made for the most part. The next thing is, to me, NERSC is the clients and users. I like to call them clients or partners, not just users. Users are addicted to machines. I know some of you are. Clients you have a long-term relationship with. NERSC's philosophy, you heard some of that earlier today. The staff and the resources, the physical resources, you notice that this is a little bit in priority order, where the resources are not the primary thing, even though we all talk about how many times we've been on some list or how many aggregate floating point operations we have. The funders deserve an awful lot of recognition as well. They're incorporated when I say the term NERSC. The leaders, going back all the way to John Klein, all the way up through all the leaders today. The academic partners like Berkeley, like Davis, and like some of the other partners, and all the associates, collaborators, and friends. So when I say NERSC, I'm talking about the big picture NERSC, not just simply machines. I was at Supercomputing 07. Dr. Ray Orbach, who then was the Undersecretary of Science, said, and I think this is a really important quote for NERSC, NERSC was and is today the best run computing facility in the world. And that's what he said. He caveated computing to say keep capacity computing in the world. That was a political thing that was on the text of his slides. That's not what he said. So well, you remember that, but that is actually quite an accomplishment, and someone else chimed in the universe rather than just the world at that session. So I thought maybe it takes a moment to have a historical perspective, not just of NERSC and what systems or where NERSC happened to be and what it was titled or labeled at the time, but how does it play in the general community of high-performance computing? And I restricted myself to the US high-performance areas. So in the beginning, there was NERSC, and NERSC is MFE CC or whatever. Oh, cut it off a little bit, but NERSC and ESNet. I don't talk too much about ESNet, but they certainly play a significant role too. The stars are notable things. We can. I won't go into each one of those things that I thought was notable. And then, from my perspective, next was NASA. In particular, NASA Ames. And I'll tell you why I think that was next in the next slide or so. But the next major facilities that are national-based, science-based facilities that are open to some multiple sets of communities is what I'm looking at. Then the NSF follows soon after NASA with a set of 5 centers down to 3 centers, then added a few more centers and whatever. But also in there is NCAR. Tom is here. NCAR actually predates NERSC. That's the only program I found that predates NERSC in terms of a computing facility. But it is a single discipline domain, at least for the most part, where NERSC is multiple domains. And I think that that's important later on. And then the DoD High Performance Modernization Office comes in, and the classified computing, ASCII and its other activities about that time period, and then the leadership facilities for the Office of Science. So this is roughly my time frame, everything in the gray arrow. There are always center-based activities or small activities or experimental activities going on. But these are national infrastructure, national facilities for people to do the science as opposed to studying things. So you'll see in my comments, but basically from what NERSC had started, the open, interactive, multidisciplinary support for many things from there directly had major influences both on the NASA program, where it started with NAS, around its center-based machines, and the NSF program. So if you go back and look at those programs, they derived much of their philosophy, much of their approach from what NERSC was doing earlier. And this is probably one of the most important contributions besides the science impact of enabling thousands and thousands of the nation's best scientists and data analytics people. The next thing I think for our community is it influenced these activities, and then eventually also the same type of philosophy here in the DoD. But then these groups, just like everything else in science and engineering, the cascading effect of what is discovered then cascades into other things discovered or revealed. And these programs became very strong and others modeled off of that. So I think that this is an important thing that we should keep in mind about the influences that NERSC has had. So I'm going to go through my view of some of the great legacies of NERSC over this year. And the first is it was the first multidiscipline, nationally based HPC resource for diverse and open science. So some of the changes that we talked about this morning or this afternoon about moving from Livermore computing, central computing on forward, was to make it open and a little more open. Only local centers were before that. ECC and its precursors started to open up with some of the connections we heard. JED's, wherever he is, Opera connection, that was Sub Rosa. But in most cases, there were local centers that maybe you could dial into with a modem or something like that. Contemporary shared supercomputing was a single discipline, NCAR, even MFECC, where it was originally envisioned before it started to open up with IEEE's was focused on a discipline. And what NERSC did is taught the rest of us how to do that type of computing. They certainly engaged with NASA. That was my first interaction with NERSC about that program as it was starting up in the early 1980s, NSF, DoD, and obviously then now international centers. So NERSC was the first there and has pursued that and expanded it over and over again. Next legacy, the first center to commit production for MPP or whatever you like to call it, highly parallel distributed computing, whatever you like to call it. When the T3 came here, NERSC had made the decision with DOE that parallel computing was the production computing of the future. Almost every other place around was experimenting with it, trying it, doing things like we heard about the T3D at NASA Ames. We had an Intel IPSC 860 a connection machine, a couple other parallel machines, an IBM SP even. But they were not the production resource. They were kind of trying things out. NERSC, as far as I'm concerned, is the first place that made that commitment and said, I'm going to put almost all my resources, almost all my focus, and all of the production science on parallel resources. So the T3 was that machine. Again, that's another thing to thank Livermore and Mike McCoy for, because he was the one that figured out how to do that contract along with Lynn back there and Daryl Hammer, and then quickly switched it from a T3D to a T3E. That arrived here, and it was the first major production resource that at least I know of. And then with the user community, NERSC was committed to going down that path. We did have some vector machines, but within about a year of the full T3 being here, all of the disciplines, fusion all the way through high-energy physics, through astrophysics, all the disciplines had more time and were doing more computing in the parallel system than on the more traditional vector systems. And now we know that there's only that style of computing in the supercomputing environment until we get to maybe clouds. The focus on science is another legacy NERSC leaves that we all benefit from. Interactive supercomputing equals productive scientists. We heard many stories about how that was different, how NERSC and before that Livermore were doing interactive supercomputing. That was the precursor to also applying Unix, which we did at NASA Ames. But several of the NSF centers use CTSS, as well as a number of other sites, including some industrial sites, because of this and realizing it was more productive. And the exceptional customer service that was commented on is also an integral part of NERSC. It wouldn't be just having machines. Nobody expects it there. Although in many other situations, many other organizations, you just have the machine and people suffer through trying to make use of it. So NERSC is a standard candle. I know standard candles are a special term here at Berkeley with supernovas. NERSC is a standard candle for quality customer service in the high-end computing. But we also know that it takes a lot of hard work and innovation to provide that. So it's not just the innovation comes from the next generation chip. The innovation comes from actually helping and figuring out how to make that set of technology the best it possibly can be. And almost all those methods are adopted in the DOE leadership centers, as well as NERSC being the place where people come. If you're going to do a document on best practices for how to have a center or how to provide facilities, NERSC is the place everybody needs to come to find out how to do that. Other great legacies is a whole variety of software, either improvements or basic software that come from NERSC and its associated other parts of activities, be that fully within NERSC or being it associated with NERSC, like some of the research organizations here or at Livermore. The ones I thought of were the enhancements to MPI and its use, converting from or moving the community from PVM to MPI. Data management, R.A. Shoshone and its implementation in all the large data activities that go on. Visualization, adaptive and load balancing techniques like AMR, the I/O and storage activities. We'll talk a little bit more on programming models, UPC, other types of things. Cyber protection, I think, is one that maybe we don't think of all that much, but I think, at least from my view, there's no place better than Berkeley and NERSC in terms of cyber protection for large machines that don't interfere with how you can use those machines. And then obviously lots of applications, astrophysics, microwave background radiation, supernova, all those other things, climate materials, and goes on. And the contributions to those applications that were made by NERSC staff and along with the science teams are all great legacies. So I submit to you that NERSC merged big compute with big data before we even knew what those terms were. And NERSC has been doing that for at least a decade and a half, if not longer. We all know that in high performance computing, we all think that we handle big data along with big compute. That's true. That's inherent in some of the activities of simulation activity. But the fact is, I think NERSC, who was the first place that merged high performance simulation computing or computational science with high performance data analytics of observed data. Be that bringing the observations in for studying detecting supernova, or for the PDSF, high energy physics and nuclear physics activities. But they were merged here, and I think that was probably first in any organized manner with an infrastructure, with an activity that meant to merge those. In fact, the mention of the T3 and the PDSF, they actually arrived here at Berkeley on the same day. All of the Cray, I should say, all the Cray components from Livermore arrived here with the PDSF on the same day. They arrived in one truck for all the Cray stuff, and in 4 trucks for the PDSF, all taken out of the superconductor. So they arrived from the very beginning, and from that day on, this synergy of data and computation, data analytics and computation, has been an important thing that NERSC has pioneered. The HPSS collaboration, of which NERSC is one of the developing partners, the Global Unified Parallel File System, that was generated, the first ideas for that were generated because the experiences with the T3, when we had 2 T3s, if people remember, we had a small one and a big one for a while. Turned out we thought people would get on the small one, do development, interactive, and then they would move to the big one for production runs. We realized after several months that nobody was moving because their data, they had 2 separate file systems. And people did not want to go through the hassle of moving their data back and forth between the two. So that once people that started using the small one, stayed on that and wanted all the same services. About a year later, those 2 machines were merged into a single machine for that purpose. But that was the spark that said, gee, this idea of having a global namespace is important. Everybody else did it with the network file system, slow, unreliable, insecure, and NERSC did it, envision that with a highly parallel, high-performance file system. And it's emulated elsewhere. Sometimes we ship people off and let them stay a while. It's places like Oak Ridge, and then have them come back. Other places have incorporated these ideas as well. But I will say that also in the same time period, many failed trying to do the same thing, and NERSC succeeded. So Sudeep showed a slide, more data comes to NERSC than leaves. That's not new. That's been going on for a long time. The other thing that's important is, at least in my time here, a high percentage of that stored data is actually used, which is unusual. Everybody says, oh, it's the closet, you throw it away and never think about it again, it's in your basement. It may be different now, but we looked at that, and a lot of that data is actually used at least once, and it's useful. So this merger, now what maybe people call BDAC or all types of things, actually has been going on for 15, 18 years at NERSC. The focus on real performance is another legacy. Real-time the solution equals real sustained performance. The system choice is going way back in Livermore days. We're all based on what really is driven by the science needs and getting that work done. And I think that while I like to think other organizations do that well, I think that at NASA we did something very similar. But I think for consistency and beginning to do that, NERSC has been one of the leaders for that. And also some of the methods here have been adopted by many others. And I think that will continue with that. Another thing I think NERSC paves the way for or shows is how to express the impact of the use of the resource for the real science. So this is the thing that we struggle with in NCSA and NSS space. How do you show the impact of what you're really doing as opposed to if you didn't have any of those resources? NERSC has done an outstanding job, and now lots of people emulate that in trying to show this very hard thing, right? So we all have the traditional methods of citations or papers or whatever. Some of those are volume-based. The more users you have, the more papers you'll have. But how impactful are they? Well, we think about citations, right? They take a long time to lead up to. NERSC has a wonderful history of showing that. But also the uniqueness, the fact is what you have is unexpected insights as well as the planned insights or the planned campaigns. So NERSC has done a great job with that. I think many other organizations are trying to do similar things, and not only are we trying to do similar things, we also benefit from what NERSC has done, and we leverage that there. So this is one of those little stories I don't know how many people know, but I'll claim that NERSC was a primary mover to reinvigorate the federal supercomputing funding, and particularly for open science. So in about 2004, there was a meeting here with Ray Orbach. He happened to be a friend and a colleague of Chuck Schenck, and Chuck asked him up here before he reported to Washington to become the director of the Office of Science. And a few of us, Bill McCurdy, Hoss, myself, I think were the ones in the room with Chuck, talked for about half a day with Ray about the importance of high-performance computing, its issues, its motivations, its benefits, and this was surrounding the time period about when the Earth simulator was coming out. But it was all focused on the science, not the top 500. I don't think we ever mentioned top 500 in that meeting. It's hard to prove cause and effect, but we all know that since that time period, federal budget in high-end computing has doubled, more than doubled in actual dollars. And if you look at the open computational science, because in this time the federal budget was dominated by classified work, particularly ASCII, and some other things, the DARPA work, the open science share of the funding much more than doubled. So something else that NERSC and Berkeley helped create that's benefited more than just the NERSC site. NERSC systems are entirely open and on the internet. That's a fundamental philosophy for this interactive use. And the fact is that we want to get the maximum amount of bandwidth and performance for data transfers for everything else. But that leads to the need to still make sure that they're protected. And I think, as I said, NERSC is a leader in this, along with Berkeley for cyber protection. I like to call it cyber protection rather than security. Someone from Berkeley actually asked me, would I rather have my home and town secured, or would I rather have it protected? And secure, I think, is, I'd rather have it protected, right? So the methods of BRO and all the other things that go into the cyber protection infrastructure have led the way. We use that at Illinois. Other people use that as well. And it actually now has been codified in the science DMZs that are being implemented with ESNet and NERSC. And actually, there was a paper in supercomputing this year, made a very good impression on lots of people. It's what NERSC and ESNet were doing 5 or 6 years ago, but now documented. Monitor and react philosophy for major systems so that they're not behind firewalls, things like that, make them performant and easy to use, is something that's being trying to be adopted by others. NERSC influenced a lot of policy, particularly on those things that would have made more restrictions. And Berkeley worked on this to maintain the openness and effectiveness. But this only really works. You only have one bad experience, and you'll have lots of implications. So the fact is, it's worked for 15, 18, 20 years without having a major issue, where many other places had major issues with security, shows that this methodology is a legacy that others should learn from. Another legacy I thought of is NERSC's ability to manage both grand challenge activities and I don't like the term capacity, but the use of the systems for many, many projects, plus a few very large, important projects. That takes a particular skill at managing that and working with the clients to make sure that that works. Persistent support. Another legacy as part of that is NERSC actually started the DOE Insight program. So we were the first place that actually started Insight allocations. The first one happened to be, that I remember at least, were colliding black holes. Ed Seidel did that, and Ray Auerbach gave him a special allocation out of what became Insight to get away from just doing lots of small things. He wanted to do grand things as well. Small world. Ed now is my boss at NCSA. So that's the first time I met my new boss, and it was about 15 years ago. But it shows great steps forward can be done while giving large resources to a set of well-qualified teams. So it proved that, but it also meant that you can manage very large work without also being very disruptive to the general, there's not a good term, smaller jobs or regular jobs. But NERSC is able to do that on a day in, day out basis, and it makes a very big difference. The other thing is, I don't think there's a better place at the moment for people in this middle range of being able to scale up, but not having enough time or resources. There's not a better place or advocate than NERSC is for the missing middle, as it's sometimes called. Science first has always been, this is a repeat of that one, sorry. Too much cutting and paste. I would also submit that NERSC reinvigorated high-performance computing at Berkeley. When we came to Berkeley in 96, Berkeley did not have a single allocation. There wasn't a PI with a single allocation on NERSC. About 5 years later, NERSC had the majority of, or the largest allocation share by institution there. And it was through, not just the fact the machine is here, I don't think that that was a major issue with that. It was through the programs that I think Peter alluded to, the LDRD funding that Berkeley put in to join NERSC to build up a computational science expertise at Berkeley, knowing that that was going to be the future, maybe more so than experimental theory, at least at the moment. So within 5 years, Berkeley had the majority by institution of NERSC allocations and built the strong programs. And the synergies have enabled new discoveries, and as you heard, at least one Nobel Prize came from that type of synergy. So that legacy also is an important one for NERSC. So you can't talk about NERSC without talking about vendors. Jeff is going to talk from perspective. And we all know that relationships between facilities and organizations like NERSC and the vendors that supply the technologies have I want to put up there a love-hate relationship. Maybe it's a give-take relationship is a nicer way to do it. The best value processes that were started at Livermore and I think have been pushed a lot at Berkeley and NERSC for holistic evaluation. Is actually something the vendor community likes from everything they've said. They may be being nice to us, but from everything they said, they like that much more than the very prescribed methods of acquiring machines before. NERSC helped many vendors get better, get good, all the way up through many variations of Cray, vectors, MPPs, IBM. The things I thought of were the SP at scale, and then making the SP bigger, twice as big as it was before, finding out how that worked, the Power IH architecture, starting with the Power 5, GPFS, HPSS, networking vendors, several of those where there's been explicit help, and I also know storage vendors, and I didn't remember all their names. The only one that stuck in my mind was Yada Yada, so I know that they're out of business, but a lot of the storage vendors as well, all benefited from the experience and the activities, be they in production or be they in some of the evaluation phases here. NERSC made some hard decisions. Bruce talked about the Cray computer decision. Those were hard. They were disruptive to at least some parties, but they ended up in retrospect to be the right decisions for the HPC community. And everybody knows that NURSC is honest, fair, and gives a meaningful opinion or evaluation. So while you'll always have this give and take in terms of the individual interests between the vendors and the organizations and the science community, in general, I think there's been a lot of strengths and a lot of benefits coming from NURSC and its use of interactions with vendors. Not too long ago, again, thinking about how Impact has done an expert in evaluating things, told me that a measure of impact is the diaspora, the spread of alumni from organizations. And in many cases, those attract, particularly in some other fields. Where do people go? Where are they having continued impact based on what they've acquired, the experiences they've acquired? Well, first I want to point out that NURSC benefited from this from others. When we came here to Berkeley, I think we were able to get best practices from the entire world because we're able to hire the people that were doing that as a practice from other places, like Francesca, like David, like Harvey, and all the other folks at NURSC. So we accumulated that at NURSC, and that benefited us tremendously. But there's also the spread of people who have been at NURSC and gone on to other places. I would say Shane brought a lot to Oak Ridge when he went there, and we're glad that he's back. Other people have as well, and that's an important impact for the community and for furthering science as well. So that's a key thing to keep in mind. So my summary is that NURSC was the first. NURSC is there the longest. NURSC is open science at unprecedented scales and impact. NURSC is the perennial leader in our community. And the nation, DOE, and the supercomputing community should not only be proud, but thankful for NURSC. So that's what I want to leave you with, because it is true. And then here's paraphrasing Ray. I will say NURSC is today, and will be in the future, one of the 2 best run HPC computing facilities in the world. I'll let you guess what the other one is that's on my mind. So happy anniversary, and thank you very much.
Well, wow, thank you, Bill. Anybody have any questions or comments for Bill?
Please add correct. I probably left out about another 15, 20 things about legacies. So if you have one, then let me know and we'll put it on the list for the final documentation.
Okay, if there's no questions, thank you again.
Thank you.